This video is for the VARTM Clipboard layup assignment. To begin the layup process, all the plies must be tacked together. Lay a carbon fiber ply down on brown paper and spray the corners lightly with spray interface tack spray. Then place a fiberglass ply on top, ensuring the two plies are aligned as close together as possible. Use a roller to smooth out any wrinkles. Repeat this procedure for the next 3 fiberglass plies. Finish off the fabric packet with a carbon fiber ply. Once the packet is complete, trim away any frayed edges with scissors. Next, the packet is placed in the center of a prepped glass plate. Gently flatten down the plies and remove wrinkles with a roller. Lay the peel ply on top of the packet, making sure to leave a 1/4 inch overlap on each edge. The injector plate is next. It will help provide a smooth flow of resin throughout the part. Transfer medium is the last element of the layup stack. This concludes the initial part of the layup process. For the next part, it's beneficial to remove your rubber gloves. A section of sealant tape about 4 inches long is stretched to cover the top edge of the transfer medium, sealing it to the injector plate. This is the side opposite of the angled channels on the transfer medium. Peel ply should be slightly visible from underneath the tape. A 2x2 piece of transfer medium is then butted up against the sealant tape above the part. This will be the outlet port for any excess resin. Sealant tape is then run along the outer perimeter of the part, covering both the transfer medium and peel ply. Blue flash tape may be used to keep the part from sliding, but needs to be removed prior to laying down the sealant tape. The overlap should be about 1/4 of the tape width, with the majority adhering to the glass. This process should be done with care to ensure a good seal is made while maintaining proper ply positioning. Small strips of sealant tape are placed at the apex of the inlet side and the top of the outlet side. Next, sealant tape is put down on the outer perimeter of the glass plate. 1/4 inch should be left between the edge of the glass plate and the outer edge of the sealant tape. Metal tubing is then placed on the inlet and outlet sides of the part. The outlet tubing should be centered inside the 2x2 piece of transfer medium, while the inlet tubing is centered from left to right and about 1 inch inside the tip of the channels. The opening of the tubing should be parallel to the glass plate. A small strip of sealant tape is then placed over the top of the tubing to secure them in place. Once the tubing is in place, a second layer of sealant tape is then placed around the first perimeter of tape, overlapping it by about a half. This is to ensure an airtight seal around the part and ports. The technique of using one long, continuous strip of sealant tape and bending it around the corners is done to minimize locations for possible air leaks. Breather material is subsequently placed in between the inner perimeter of tape and the outer. There should be no overlap between breather and sealant tape. However, overlap of the breather pieces is essential. Breather aids in removing all trapped air from the part when vacuum is applied. Overlapping assures this task is done properly. Another piece of breather is placed in the corner underneath the female end of a vacuum port. After all the breather is in place, bagging material is placed over the top of the entire project. It's a common technique to start from one corner and work your way to the opposite corner, stretching the material tight over the part to minimize wrinkling of the bagging material. Once the corners are secured, the sides are pressed down, firmly sealing the bagging material to the tape.